This is section 1.3 and 1.4 for Math 110. And we're going to be talking and just quickly going through things that you should know about lines in the plane and slopes of lines. And on the flip side, we'll talk a bit about functions. So this is an algebra review. It should help you be able to get through the WebAssign that you're going to be doing on this. And you can fast forward through anything that you find that you already know. So anytime you're going to write the equation of the line, it doesn't matter to me if you use slope-intercept form, which looks like y equals mx plus b, or point slope, y minus y1 equals m times x minus x1. I don't care which one you use and which one you leave it in. Sometimes WebAssign will be picky about it. And the slope, you know, hopefully is a ratio between the rise and the run. So you can think about it as the steepness of a ramp or the rate of change of a variable. Lots of different ways to think about it. But a couple examples are if you had to write the equation of a line that goes through 2 points. The first thing that you'd want to do is find the slope. So the formula for slope we talked about before, but it's y2 minus y1 over x2 minus x1. This being x1, y1, and x2, y2. So you're going to calculate 10 minus negative 3 over negative 5 minus 2, which is 13 over negative 7. And then to write the equation of the line, you can say y minus, I'll use the first point, negative 3, so we can change that to plus and positive 3, equals negative 13 sevenths times x minus 2. And you could distribute and move the 3 to the other side if you want, or you could stop right there. But you're not going to see a problem like that. In calculus, it's going to be more of a question of finding a word problem and using it to come up with the equation of your line. So for example, the cash flow per share for Ruby Tuesdays was $2.51 in 2004, and then it rose to $2.79 in 2006. Using only this information, write a linear equation. So that's what's telling us we're going to use an equation of a line that gives the cash flow per share in terms of the year, and then predict the cash flow for 2008. So one thing I like to do to simplify things a little bit is I'll let T stand for the year, but instead of using 2004, I'm just going to use the ones digit of that, and I'm going to use the number 4. So I'm going to match a T value of 4 with a money value, which is the cash flow of $2.51. And then I'm going to match a T value of 6 with $2.79. It's very important to remember that anytime you are creating linear equations in business calculus, the money is going to be on your y-axis. And the year or the time is going to be on the x-axis. So these 2 points written algebraically would look like this: 4, 2.51, 6, 2.79. And it's very common that students mix up and use the wrong thing for x and y. It's always going to be the money that's y, so you have to remember that. So then once I know the 2 points, I can do it just like I did number 1. Find out the slope by subtracting the y values and putting it over the x values subtracted. So I'm going to get 0.28 over 2, or 0.14. And then we'll write the equation of the line. Y minus, I'll use the first point, equals 0.14 x minus 4. And then I can distribute if I want to distribute. And the reason that I might want to do that is this last sentence: predict the cash flow for 2008. So in order to do that, I want to figure out when T is 8 what the cash flow is. And I could just add 0.14 twice, because that's the slope. Or I could could plug the 8 in here and subtract and then multiply, or I could distribute here and get 0.14x, here and get 0.56, and add the 2.51 to 0.56 and get 3.07, and then plug in the 8. Whatever makes the most sense for you is what you want to do. But predicting the cash flow, you're going to plug an 8 in where the x is. And then finally, the other kind of linear situation that we have in Math 110 is the idea of devaluing something. So for example, if you have machinery that you have bought at $12,000 and they tell you its useful life is 8 years, and after that the salvage value will be $2,000, you can write a linear equation to describe how that book value goes down each year. Now that's a huge simplification because when things devalue, they don't devalue in a linear fashion. But just like we talked about supply and demand the other day, you're not going to be able to write the equation of a curve. So anytime that we have something that is devaluing, we're going to assume it's in a linear fashion so that we can deal with the algebra of it. So in other words, this piece of machinery started out at $12,000, money on the y-axis, ended up in the end being worth $2,000. And that happened over the course of year 0 to year 8. That's the linear equation I'm trying to write. So in this case, y equals mx plus b might be the better way to go because I know what b is. I know what my y-intercept is, 12,000. And I can figure out my slope by taking the 12,000 minus the 2,000 over 0 minus 8. Notice how the order I did it is important. I got to match the 0 with the 12,000 and the 8 with the 2,000. But I should end up with a negative slope, so I know that I did it in the correct way. So I'm going to end up with negative 125. And now my equation for my book value is that the y is equal to negative 125x plus 12,000, which was my y-intercept. And so I could figure out what it's worth at any year in between 0 and 8. And if I use this equation to do that, finding out the values in here is called interpolation. Whenever you use some kind of a model that you're given to make a determination about some data in between two pieces of data that you already know, you're interpolating. If you try to go beyond year 8, you really can't do that because that's as low as it's going to go. But if you tried to plug a 9 into this equation, you'd be extrapolating. And in this case, the extrapolation wouldn't make any sense because this model ends right here. All right, on the flip side of your page, we have some function notation that you need to have learned in Math 22. So if you have, you'll understand all of this, and if not, this will be a quick review. A function is a relationship between variables such that to each value of the independent variable, which is where we put on the x-axis, there corresponds exactly one value of the dependent variable, which we put on the y-axis. And that's why we use the vertical line test to determine if something's a function, because if a vertical line touches the graph of of the function or the relation we've drawn, if a vertical line can intersect it twice, then it can't be a function, because one value of x would match with two different values of y, and that's not allowed to happen in a function. We've talked a lot about the domain being the set of all values for x and the range being the set of all values for y. So you want to know that vocabulary. And piecewise functions. We touched on that a bit too, but just as a quick refresher, if you have a piecewise function that breaks apart at the value 1 on the x-axis, then what you need to do is look to the left of the number 1 and graph the function 1 minus x in this case. Meaning if you plug the number 0 in, you have to plug it into the top piece of this function where x is less than 1 because 0 is less than 1, and you'll get out the value of 1. And if you plug in the number negative 1, which again would go into that top piece, 1 minus negative 1, you'll get out the value 2. And that makes sense because 1 minus x is the graph of a line with a slope of negative 1 and a y-intercept of 1. And so you could draw that line, but you have to be very careful when you get down to 1 because you're not allowed to plug the number 1 into this top piece. So we put an open circle there to mark where we're headed, but we can't quite get to on that top piece of the function. And then we move to the bottom piece of the function. And if we plug the number, let's pick a good number. Let's say the number 5. When x is 5, we are at x value greater than 1, we're going to plug into the bottom piece and get the square root of 4, which is 2. If we plug in 4 or 3 or 2, any of those values, we're going to get numbers that are less than 5 but greater than 1. They're going to be a part of the square root function. And we are allowed to plug the number 1 into the bottom, and when we do that, we get the square root of 0. So now we could fill that open circle in with a closed circle from the left-hand side. It's not closed from the right, we close it in from the right-hand side as this comes in toward the number 1. It's not closed in from the left-hand side, but it is closed in from the right-hand side. So if I changed my piecewise function and made a little adjustment, and I didn't change the bottom, let's say, but I changed the top to be 1 plus x, what would happen is this point would now move up because my line would be the line, the line would be the line with a y-intercept of 1 and a slope of positive 1. So the slope would change and it'd be coming up. But I'd have to put that open circle on the end again because as I come up on that 1 plus x line, I'm headed to here, but I can't get there when I use values that are always less than 1. So changing a function, one of the pieces of the function is only going to change half of your graph. Finally, getting into function notation. You know that if you're evaluating a function, whatever I put in parentheses is going to go into the x value. And so in this case, f of 6 is going to be 6 squared plus 6. And you can add that, multiply and add and get 42. F of h is going to be h squared plus 6, because the h is going in that same spot. And f of x plus h, which is going to be real important later on, just literally means you put x plus h in where the x is. So f of x plus h is x plus h squared plus 6. So you're evaluating this function x squared plus 6 and you're putting x plus h in instead. You could FOIL it out if you wanted to. And then composite functions. If you have f plus g, that means just add your functions together. So in this case, x squared plus 3x minus 2, the f function and the g function. Subtract your functions. If it's f minus g, but you have to be very careful when you subtract to use these parentheses, because otherwise you're not subtracting g, you'd only be subtracting part of g. So better to write it as x squared minus 3x plus 2 when you distribute that negative through. This is multiply, so you would have x squared times 3x minus 2, or 3x cubed minus 2x squared. This is divide, so you're going to have x squared over 3x minus 2, and you want to make sure that you make the domain connection there, that's going to mean that x can't be 2/3. It could be for f and it could be for g, but not when you divide them. This I like to read as f of g, which means you plug g into f. And so what that's going to look like is this 3x minus 2 is going to go into f. So it's going to be f of 3x minus 2, or 3x minus 2 squared. And then you can plug f into g on the flip side, plug x squared into g, where the x is. And so that's going to look like g of x squared, which is 3x squared minus 2. So anytime you plug into another function, you plug into where the x is in the other function. Whatever's happening to x in that other function is what's going to happen to this thing you're plugging in for x. So if x was multiplied by 3 and then 2 was taken away, x squared will be multiplied by 3 and 2 will be taken away for g of f of x. Okay. Quick review of sections 1, 3, and 1, 4, just to get you ready for that web assignment.